Hello, everyone. Welcome to First Online University, a global platform for all your education and growth related needs. In this lecture, we are going to begin with a discussion on hydrocarbons basically, and we will be touching a bit upon alkanes. So, this is going to be a very general discussion lecture on very basic of organic chemistry, that is hydrocarbons. And then we will be taking this topic to higher alkanes, and then alkenes, and then alkynes. Before we begin, a piece of information for you. You can use the coupon codes Mission J or Mission NEET while you enroll at First Online University for Mission J or NEET. Now, a brief study of hydrocarbons and an introduction to alkanes. Before we start with alkanes, it is important that we know what hydrocarbons are. Now, as is clear from the name hydrocarbons, hydro means hydrogen, carbon means carbon. So those compounds that contain hydrogen and carbon are called hydrocarbons. Now, what are hydrocarbons? The compounds containing carbon and hydrogen are called hydrocarbons. Hydrocarbons play a very important role in our daily lives as well. So, answer this question. Can you give me some examples for fuels that we use in our daily life? Go to the kitchen. What do we use? LPG. You travel in vehicles. Petrol, diesel, CNG. All these are what? These are hydrocarbons only. LPG, liquefied petroleum gas that you use in cylinders or these days in gas pipelines also at your homes, in your kitchens. CNG, that is compressed natural gas, which is used in cars, vans, buses, etc. Then LNG, that is liquefied natural gas, which is nothing but your petrol and diesel and all. So hydrocarbons are used in fuels like CNG, LPG, etc. These are used for manufacturing of polymers as well. For example, if I say PVC, PVC is what? So you see PVC coatings on the walls, on the roofs. So PVC is what? PVC is polyvinyl chloride. Apart from that, we have polypropylene, polystyrene, polythene. All these are examples of polymers that are born from these basic hydrocarbons only. PVC pipes. They're also used for the manufacturing of dyes and drugs. Pharmaceutical industry, dye industry also makes use of hydrocarbons. Now let us start classifying hydrocarbons. Hydrocarbons are based on basically the bonds. The classification is based on the bonds between the carbon atoms, and they can be classified into three categories. Number one, saturated hydrocarbons, unsaturated hydrocarbons, and aromatic hydrocarbons. Let us see a few examples for each of these three classifications. Talking about saturated hydrocarbons. So if we look at the simple structure, which has all the single bonds, there is no multiple bond present. These are saturated hydrocarbons. Those hydrocarbons which contain a double or a triple bond are unsaturated hydrocarbons, and those which contain, this is another example for unsaturated hydrocarbon. Coming to aromatic, those hydrocarbons that contain a benzene ring are called aromatic hydrocarbons. So not necessarily a benzene ring, those which contain conjugated double bonds, basically. They satisfy the 4n plus 2 Huckel's rule. They are planar compounds, and they obviously have conjugated double bonds. So these 3-4 conditions, if are satisfied by a particular compound, it will be termed as an aromatic compound. Now, let us talk in details about these saturated, unsaturated, and aromatic hydrocarbons. Now, what are saturated hydrocarbons? The hydrocarbons containing single bonds only between two carbon atoms, for example, alkanes and cycloalkanes. Unsaturated hydrocarbons are those which contain double bonds or triple bonds between two adjacent carbon atoms, for example, ethene, ethyne. And aromatic. So, what are cycloalkanes first of all? Those saturated compounds that contain carbon atoms in a closed chain or ring, these are cycloalkanes. For example, if I say cyclopropane, a simple triangle, or you can say cyclobutane, a simple square. Okay. Now, let us start talking about alkanes. Now, alkanes are basically inert under normal conditions, and hence alkanes are also called paraffins. These are those saturated open chain hydrocarbons. Saturated means they contain only single bond between adjacent carbon atoms, and they are open chain hydrocarbons containing single bond between two adjacent carbon atoms. For example, methane, ethane, etc. So if you see these examples, coal mines or marshy place, this is where you get the alkanes from. Now, alkanes have the general formula CnH2n plus 2, where N starts from 1, 2, 3, and can go on up to as much as 20 or 40, like that, where N is the number of carbon atoms. Now, if N is equals to 1, the molecular formula of hydrocarbon is CH4, which is methane. That is C, N is 1, H2, N plus 2. N is again 1, so you calculate, H turns out to be 2 into 1 plus 2, that is 2 plus 2, which is 4. Now, methane is also known as marsh gas or fire damp because it is obtained from either coal mines or marshy areas. If N is equals to 2, molecular formula of hydrocarbon is C2H6, which is ethane. Other alkanes are C3H8, that is propane, C4H10, that is butane, etc. So alkanes, they come under a homologous series. Now, what is the definition of a homologous series? A homologous series is a series of compounds which are represented by one general formula. So all these alkanes can be represented by one general formula, and the differences between any two compounds of the series is going to be just by a CH2 unit, or in terms of molecular weight, the difference is just going to be 14 units. That is called a homologous series. Now, if we look at the structure of alkanes, in alkanes, the CC and CH bonds are formed by head-on overlap of sp3 hybrid orbitals of carbon. So, carbon has sp3 hybrid orbital that is going to head-on overlap with the round s orbital of hydrogen atom. So, this is the kind of overlap that we have. CC bond length in alkanes is generally 1.54 angstrom, and the CH bond length is approximately 1.12 angstrom. The carbon in alkanes is tetrahedral carbon. If you look at this figure, it's a tetrahedral carbon in gray that is represented, and all these blue atoms are going to be the hydrogens. So this is where we have the example of a methane. So all the bond angles are going to be equal to tetrahedral bond angle, which is 109.5 degrees. Now, if we look at the structural formula, which is CH3CH3, or which is, CH3CH2CH3, the condensed formula would be C2H6. Okay, so we can write it like this. So condensed formula is where you remove the bonds and you write it like that, and molecular formula would be C2H6, C3H8. So you should know the difference between structural formula, condensed formula, and molecular formula. So this is the representation This is going to be dot and cross formula. So if you see, the electrons of carbon are represented by dots and the electrons of hydrogen are represented by cross. So this is a dot and cross formula. Similarly here, so we have studied four formula in this slide. One is the structural formula, one is the condensed formula. The structural formula where you have these carbon atoms separated by bonds. Condensed formula where these bonds are going to disappear, rest of the things are going to remain the same. Molecular formula where you just have to write the number of carbon and hydrogen atoms. You do not have to write the entire structure. And dot and cross formula where you have to represent the whole structure in the terms of the electrons around carbon and hydrogen. And in order to distinguish between the electrons of carbon and hydrogen, we have simply used dots to represent the electrons on carbon and cross to represent the electrons on hydrogen. This is another form where this is called the line representation or line formula. So this adds to the different formulas. So structural formula, condensed formula, molecular formula, dot and cross formula, and the fifth one is the line formula. Now, if we look at alkanes, we see that there are two types. One is straight chain, the other is branched chain when we are talking about alkanes and not cycloalkanes as of now. Straight chain would be this example, branched chain would be this example. Now let us classify the carbon atoms of alkanes. Okay. So when I have to classify the carbon atoms in alkanes, what is a primary carbon atom, secondary carbon atom, tertiary and quaternary carbon atom, 1 degree, 2 degree, 3 degree and 4 degree respectively. So what is primary carbon atom? The carbon atom which is attached to only one carbon next to it is called a primary carbon. Secondary would be the one which has two carbons next to it and two hydrogens. Tertiary carbon which has three carbons around it and rest one is hydrogen, and quaternary carbon which has all four carbon atoms in its four bonds. Okay. Let us look at the example. So if you look carefully, so let us talk about this first. Now, since this carbon is attached to just one carbon, so this is going to be a primary carbon. If we talk about this carbon, since it is attached to 1, 2, 3, it's a tertiary carbon. This carbon attached to 1, 2, 3, 4 carbon atoms is going to be a quaternary carbon atom. So now look at this. The red carbon is the primary carbon, 1 degree. This is again going to be example of a secondary carbon, which because it is attached to two carbon atoms. This is a tertiary and this is a quaternary carbon atom. 1 degree for primary, 2 degree for secondary, 3 degree for tertiary and 4 degree for quaternary carbon atom. This is very basic. Okay, you should just know. We are going to continue with alkanes in the next lecture and we will be going into much deeper details. You can subscribe to our YouTube channel for joining YouTube live classes for best NEET or JEE coaching. You can also download the First Online University mobile app for continuous learning through your smartphones. Keep learning with First Online University, a team of millions of learners and educators worldwide.